Welcome to the Demystify Technology podcast from the MacLaurin Group.
Typically, you go through the due diligence process. What the world of private equity.
Right. Can't wait. Demystify it.
Ryan Birch and Alan Williamson talk about how you can utilize different types of messaging queues to decouple applications with a focus on the three main players in AWS: SQS, SNS, and Amazon MQ. They then dive deeper into how to securely access these and other AWS services while your applications are running inside of AWS without having to pass around the equivalent of usernames and passwords.
And we're back for another episode of Demystifying Technology, and I've got Ryan here today. How are you?
Oh, not too bad. How about yourself?
Doing good, and if we're completely honest with you, we've got a third party here, which is a red plant.
It just adds to the festive spirit.
That's true. We are in the season of where the radio stations are now playing continual tunes.
Yeah, it feels a little early, but I mean,
Ding
it does.
dong.
At least the weather is a little bit cooperating with what we're talking about.
Indeed. So what are we talking about today?
So today we're going to be talking about the concept of messaging queues. There's a variety of
whole different ones.
Yeah, there is a variety of different ones. So obviously one of the big pushes today is microservices and decoupling systems, and we're going to mainly talk around kind of the decoupling aspect with the messaging queues and how you can leverage them to get that loosely coupled system that people are trying to achieve. So to that end, from a high level, what do you see being the kind of broad spectrum types of messaging queues that are out there?
So in the AWS world, for example, we've got the three big players. We've got SQS, SNS, and Amazon MQ.
Okay, so let's start with the SNS. What is SNS getting me?
So that's simple notification service.
Okay.
And that is basically where one system calls out to another system. So it's not really a queue. It's very much act time. It's moving things along. So an example of that would be a system has gone and created an event, and needs to notify another event in real time that this has now happened.
Gotcha. So a good example of that would probably be, for example, if you need to say, hey, go refresh your caches throughout the system, you would want to use something like an SNS.
Yes. Now, SNS is, there's no really fault tolerance built into it per se. Like, for example, there's three different delivery types at least. There's HTTP, email, and text.
Right.
But if that event, for whatever reason, can't be delivered, it's sort of lost at that point. So it's really there for notification as per the name of it. But it is a really wonderful technology, and a lot of people forget about how it can be used in an enterprise. So an example of that would be if you've got a classic cron type environment, we often get asked, what do you use for your enterprise cron? And cron is a legacy of the Linux world, which is basically a timetabled execution of a given file. Okay, I want this program to run every hour, every day, every first Monday of every month.
Yeah, most people are running their backup schedules and that sort of stuff on that.
Yes. So how do I trigger that in a multi-cloud environment? Do I need to stand up a specific machine just to trigger off those results? No, you don't. There are much cleaner, easier ways to do that. And one of them is coupling the Lambda scheduling with an SNS. So to your point where, hey, I need to come up in the middle of the night at 1 o'clock in the morning and do a backup. Right. Or in other cases, I need to run some housekeeping SQL statements, for example. I need to clear out anything that should be wrong, or just do a bit of a DBA type task role on this sort of stuff. SNS would be a perfect candidate to which to say, okay, there's going to be a Lambda, it's going to fire off, and it's going to trigger an API gateway Lambda, which actually goes and does the results. But that guy's somewhat dumb in terms of he'll just run when he's told to run.
Gotcha.
But somebody else is doing the sort of timing stuff. So SNS is a perfect example for that type of tool.
Okay. Well, another one you mentioned was SQS. What's that guy getting me?
So simple queuing system or simple queue system, that's more your traditional queue. So this is where you have a unit of a task or a job that needs to be passed on down for somebody else to pick up. But those jobs can be disconnected from the process that's actually executing them, right? So an example would be users were uploading files to your bucket or just uploading files to your system, and some process had to go and convert those files or read those files or do something with those files. But it doesn't necessarily have to be done at the same time as the user's uploading the file.
Gotcha. So it's starting to kind of, that's where you're truly starting to decouple and get that kind of asynchronous communication.
Perfect, and that is the key to any scaling of enterprises, is if you can decouple that process, then great. Because you could have like 1,000 files being uploaded at once, but you don't want the overhead of actually processing those files at the same time as you're uploading them. It doesn't need to be there. You can decouple that.
Right.
And then you can decouple that using effectively a queue, and you'd have a process that would run up, and the first thing that thing does is looks at the queue and say, hey, do you have a job for me to do?
Gotcha, okay.
No. Then I'll wait, I'll hang back, and I'm going to go again. I'll go back again. So to underline the first S in the SQS, the simple part, Amazon has really made it a very simple queuing mechanism in which the client effectively goes and asks the queue, do you have a job? Do you have a job? Do you have a job?
Right.
And the very nature of the technology is that it tries to only give out the job to one client at once, but we'll talk about that at a later date. But fundamentally, it's a nice, easy way to distribute jobs across your enterprise. So in the SQS world, you would have a notional queue name, and you all push jobs onto the same queue name. Now you can have as many queues as you want for the different types of systems, but ultimately it's there to decouple processes and move them around in a different way.
Okay, and in terms of the messages going on to that queue, are we talking, so your example, you use files, what data is actually going into one of these messages?
Great question. You wouldn't put the actual file onto the queue,
right?
But you'd put maybe a small packet of information to say, here's where that file lives on a file system or S3 or wherever it is.
Right.
So you give enough information in the sort of the job packet, if you will, to be able to describe how you're going to process that job. So I believe it's 4K is the maximum size, or there's a couple of different standards. There's one of them I think even goes up to 64K, and I honestly can't remember off the top of my head. But ultimately, it's a small payload, and usually you encode it in JSON, for example, to make it easier for both person putting onto the queue and the person taking off of the queue to know how to parse it and how to do it. But effectively, it's just a text blob to which you put on there.
Okay. So with SNS, just as a little bit of a recap there. So SNS is something goes out to it, and then the SNS is the active party of sending that on, whereas SQS side of the fence, somebody puts it on, and then somebody also then has to go and request that information back. Okay. And then the last one you mentioned there was the Amazon MQ.
MQ, which is their managed service of ActiveMQ, the very popular Java-based messaging queue service, effectively. Okay. Now, that's your big boy.
Okay.
That's the one whereby you want to have full control over how both you put things onto the queue and also take things away from the queue.
Okay.
It's also got a subscriber, so you get the pub sub notion. So if you would think ActiveMQ would be the sort of thing you would architect an enterprise bus with. So I have subsystems that cannot miss a message, but that subsystem in itself could be offline. Right. So if I need to broadcast, hey, somebody's uploaded a file and I need to notify the spam lot, or somebody's going to convert it into a PDF and somebody's going to put it into long-term storage, that could be one queue to go to 3 separate subscribers. But one of those subscribers could be offline. So it's up to the messaging server to hold that back to know that, hey, you haven't picked up your message yet. I'm queuing this up for you.
Right.
Okay. So I say files, but it's probably more like, think about it in an e-commerce system where if a sale would come in, then the message has got to go out to the fulfillment center, one's got to go out to the accounting department, one's got to go out to the marketing department to update the site that there's one less item to be sold on the item. One message, multiple subscribers, and you'd use ActiveMQ for that sort of stuff.
So that would be, just in relation, so that would be where normally that would be SNS, but where SNS you don't have that ability to say, make sure this gets delivered to somebody that would normally be subscribed to me. So that's where the ActiveMQ solution comes in and kind of guarantees that.
Yes, or you could just do SQS there as well. So those are sort of simple systems. The other big advantage of ActiveMQ, and again, once you're into this world, it's a different style of queuing, but the principles are the same. The clients get the message there and then. There is no polling to be done, so you actually connect to the MQ service in a continuous, think of it like WebSockets for queuing.
Right.
You don't have to keep polling. Do you have a message? 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 You sit there and wait. and as soon as a message comes in, boof, you're off to the races there. A little bit more sophisticated if you crash, or you decide that this message is not for me anymore, to put it back onto the queue. There's a lot more, what would you say, inherent housekeeping that's built into that ActiveMQ.
A lot more richer feature set
Yes.
that maybe you're starting to need for specific use cases.
But the key to that is you'll naturally evolve to that, where you'll say, hey, I just need to. So once you've started getting into that space of those questions that you'll need will naturally come out, and you'll see that there's always a service above you, 9 times out of 10, that will actually allow you to answer those questions. So you should never be at a stage of where you're home growing some of these sort of messaging systems, or you sort of resort to like using a database table as a queue system. At the end of the day, it's there to be able to asynchronously manage your microservices or your subsystems within an architecture in such a way that everything has to be up at the same time, or you have to bring things up in a certain order. It's there to be able to be in a disconnected world.
Gotcha. Okay. And so you mentioned the database table. So what's kind of the big advantage here of, because obviously we already have a database, so why would I want to use one of these services as opposed to just tossing the data into a database table?
Well, the dirty little secret there is you can, and most people do.
Right.
At the end of the day, the database table was probably the original queuing system. It's there, it does it, etc. And what the queuing system does is basically give you a much more defined interface around that. Instead of doing a select, delete, select, messaging system is a little bit more sophisticated than that. But really, when you think about it, it's doing somewhat similar to the same thing.
Right.
In sort of the Amazon world, or some of these services, they're purposely designed to be fault tolerant, whereas a database, you got to go through a little bit more hoops to be able to make that truly fault tolerant. So, right job for the right tool, but the harsh reality is that if you're using a table as your queuing system, then you're already thinking that way. So you probably should take that next evolutionary step to see, hey, maybe there's a better way of doing this.
Gotcha. That all makes sense. So let's talk about how you go about kind of accessing one of these services, right? So with SNS and SQS and ActiveMQ, well, hopefully you're not necessarily passing around maybe overly sensitive data in these messages, but you still want to be able to securely connect them and kind of, what's that authentication process?
Yes, and this is the big advantage of this world, particularly SQS and SNS. You don't have to be inside of the Amazon cloud to utilize these services. Now, if I'm outside the Amazon cloud, and we're about to touch an area to which is dear to your heart, I got to have my credentials effectively to log on, right?
Username and password.
We'll call it the username and password. Amazon doesn't call it that, but it's the username and password. It's 2 pieces of information to which I authenticate my API call to get to you, right? But there's a much, much cleverer way of doing that when you're inside the AWS world. So let's talk about that.
Secret is this big, ugly GUID, but effectively it's another username and password that's tied to a user.
So I can't use password 1 as my password.
I would not recommend it. Hopefully you have a slightly better password policy on the account, but yes. So that is usually a lot of times what we see where people kind of are using that throughout the system. So what they'll start doing is they'll create something called prod API user, right? That's an IAM user, and they use those access keys and secrets to start gaining access to other things. Which, if your system's not running in AWS, as you mentioned, that's kind of what you're stuck with, right? You need to use these tokens effectively. However, if you're running inside of AWS and you're running on AWS EC2 instances, you can have your application assume a role. And so what I mean by this is when you look at IAM, you have the concept of users and you have the concept of a role. And when you define a role is meant to be associated to another AWS resource. So effectively what you're saying is this AWS resource has this set of permissions. Okay.
Right, so let's wind that back a little bit. So we're all comfortable with the classic username and password, right? I need to get access to a database resource. Chances are you're going to give me a database name, port, and a username and password, and that's what I'm going to authenticate with. Now, what you're saying is if we're inside the AWS world, we can dispense with carrying around that extra piece of data, because that's an ugly piece of data to try and manage. And we've talked about,
You got to make sure you're securing it properly, accessing it, exactly.
And that can leak out easily.
Yeah, and at that point, you're starting to worry about hopefully like password rotation, like all that sort of stuff comes into play. Well, with the IAM roles, effectively, what they've done is inside of AWS, and I won't go into too much detail here, but effectively, they kind of abstract that layer away from you, where in reality, at the end of the day, there are some username and passwords that are these access keys and secrets getting tossed around, except it's all abstracted away. And the way it's abstracted out is the services, like the EC2 services or the other AWS services, are effectively self-managing those credentials. You said, hey, you're allowed to have this amount of access to something, and it'll automatically distribute the necessary keys and passwords. Now, how does that bubble up to your application? Well, as long as you're using the AWS SDK, the AWS SDK has built-in logic that knows how to interact effectively with that sort of invisible service underneath the covers.
You're not having to manage that.
Exactly.
And usually, it's probably good practice to stay with the SDK anyway, and there's all different languages to support it, so there's no excuse to be going to hardwiring your own HTTPS call.
And if you've ever seen, like, dealt with, especially like I've particularly have dealt with the AWS Java SDK, they're releasing a new version of that like every single other day. So they're constantly on fixing anything. They're constantly on the security side of the fence. So it's kind of like the old adage, why roll your own crypto? Let AWS do their things. They know their API is the best, so just use their SDK to interact with it. So that's, if you're inside the AWS world, I would highly recommend start taking a look at this concept of having resources assume these roles. You still get to control the same granularity of what accesses this have, but now what you're viewing it as is in terms of what does the prod API have? It's more of, okay, what should this particular server have access to?
Okay, so let's talk through a real example here. Mm-hmm. Let us say then that I have a API endpoint. Mm-hmm. It could be a Lambda.
Yep.
It could be a Java J2E some system, but it's running on an EC2 instance or a Lambda environment. And I now need to upload something to an S3 bucket. Mm-hmm. Historically, I would get my username and password effectively and make the calls to S3 to do a put object. In the role world, how does that work?
So in the role world, that EC2 instance would be associated to an IAM role. Underneath the covers and visible to you, there's going to be some access keys and getting generated and thrown away.
But we don't see that. So
you don't see that at all. Your application at that point, the SDK layer would just make a request to S3 without passing it anything.
Right, but let's come back a bit. So we create a role. Let's call it XYZ role, and we'd associate both the EC2 instance or the Lambda role or the Lambda function inside that role, and we'd also associate what the S3 bucket and key.
You would still have so to add in another object here that lives in the IAM role would be the concept of a policy. So an IAM policy is effectively where you define a list of permissions. And so this is where you go in and say, okay, I want you to have get access. Okay, I can request something from an S3 bucket, and I want you to be able to put something up to a bucket.
Right, so that's the key to the thing. Just because you're in a role doesn't mean you get open access to everything.
No, not unless, and this is exactly the way, like, for example, when you're setting up an IAM user, it's the same thing. You're going to be associating policies to them as well, or you're going to be kind of defining. So it's still the same concept of a role has a certain amount of access granted to it inside of the AWS ecosystem. It's just no longer you're worrying about the actual management itself of these username and passwords. Instead, AWS underneath the covers is handling that for you. And the SDK itself is handling that for you, so you don't have to worry about that anymore.
Right. So basically, we would create up our roles. It very much like the word definition says. It's not a single... There's not like one role to what you used to have a username and password for.
No.
A role is generally a area of responsibility,
and
functionality.
And this is one of the things I'll say. When you first step into this is where you'll start really seeing the value of the concept of the principle of least privilege. So this is a case of which you're going to do probably inevitably is when you first set something up, you're going to say, well, let me just create some access policies for prod versus dev. Right? And so here's my dev environment. What does it need to be access to? And here's my prod one. That's a great first step, just being able to separate that out. Then you're going to naturally refine that on and saying, okay, well, I have an API machine sitting over here, or a group of API machines, but then I also have a set of machines over here that are my web applications. And so you'll start dividing that up and saying, okay, well, let me create a role that's just for my APIs because the access that the API needs is different than what the web application needs. And so you'll naturally kind of find this evolution as you go along of saying, okay, well, what does this particular group or realm, whatever it is, grouping of things need access to that all kind of fit together, and that's a role for that group effectively. And then you just keep continuing it on there. You don't necessarily want to get to the point where you literally have hundreds or thousands of roles. You've gone too far.
You've lost the plot at that point.
Exactly. You want to pull it on back here. It's finding that kind of natural line of what makes sense. And like I said, to me, that's always the case of what kind of has the similar set of responsibilities and what's kind of doing the similar set of functionalities. Create a role for that group, and then you move on from there.
So from that perspective, it makes it real easy to make your code a lot more portable, because the code that's running in development and in staging and testing and all the different other environments you've got right up to production, you're not managing X number of different credentials. In many respects, that's the DevOps team or the IT team that's deciding which role that guy's running in.
Exactly. And you don't have to worry about the whole, like, how do we go and rotate these credentials? Where are we going to store them? How are we going to go grab them securely? Don't have to worry about a developer accidentally hard coding something into the Git repository where it gets checked in, because, again, you don't have these actual keys and secrets. And to that end, you may be asking, okay, well, how does my developer deal with this? Yes, they are still going to have an access key and secret, but there's a way to do that on their local machine where to the SDK, it still gets absorbed in.
And we've seen that before. So we run up in virtual machines for each of our different portfolios. And yes, we have our own credentials that are issued to us.
Exactly.
But our code isn't managing if local do this way, if production do this way.
And the buzzword here that the AWS calls this is the credential chain, effectively. So each SDK has this default credential chain. So effectively what the SDK is doing is it's kind of doing a series of checks behind the scenes to say, hey, is there credentials in this spot? No, let me look here, and it keeps kind of falling down until it finds a set of credentials. So in your developer machine, it's going to be sitting kind of towards the top of that stack. But then when that gets deployed out to an actual EC2 instance, it's going to get down to where it's finding the credentials that the IAM role is providing.
Got it. Fascinating. Okay, so as we wrap up here, what are the sort of red flags that you would say to look for to suggest that you may want to start looking at roles a little bit more?
So I would say if you're using access keys and secrets inside of an AWS environment, so if you're running your hardware inside of AWS and you're using access keys and secrets, more than likely you don't need that. That's where you could be starting to look at roles. The other bit where I would start looking at roles would be if you only have, for example, it's kind of the bookends, right? If you only have a couple of roles, like one role for everything, that feels way too little. If you've got thousands of roles, it feels like you've gone too far down the other end. It's finding that nice middle ground. To that end, like I said, it's all about looking at it from what's a logical grouping of kind of security access, right? So you don't want stuff where you're going in and if you look at a role, it's saying you get access to all of S3 and all of S3 buckets. Generally, no application ever needs access to all of S3. It only needs maybe put and delete, and it's probably only interacting with one or two buckets.
Right.
So it's just looking at it from that lens of what is that realm that it actually needs access to.
Yeah, and you're always a big proponent of least privilege.
Yes.
When it comes to issuing these roles to our policies and getting down to a layer of just what you need versus.
Yeah, and I think one pitfall here that it's very easy to fall into would be double check and look at the permissions that because AWS has a set of policies that they manage and they provide. Some of them are perfectly fine and they've all been done, but AWS has admitted themselves that a couple of the role or policies are a little too broad. So even though you may think an AAM policy managed by AWS is perfectly fine, just take a look at it just to see what it's granting. Because I will say probably one of the most common ones I see with problem with one of those is it does the S3 star one quite frequently where it says you get access to everything, and you don't really want that. But the AWS policies that they manage are great starting templates for you writing your own.
And that's the key thing, templates. You can take one of the existing policies because it's quite an intimidating JSON block of almost to look at. Yeah, there's editors, etc., but it can be quite intimidating. But modify one that's already there.
Exactly.
Way easier to tweak than it is to sort of...
Generally, they're going to provide you one that gives you the necessary permissions, and what you want to do is just start scoping it in instead of it giving you star everything, I only wanted access to my boxes that start with the name dev, for example. That sort of stuff. So yes, use it as a template and then go from there.
Brilliant. Thank you very much, Ryan.
Thank you as well.
I'm sure the plant has really enjoyed our extra oxygen here that we're sucking from it. And thank you very much.
Thank you. Have a good one.